The question is a conducting slider of resistance 10 ohm and mass 50 gram and length 10 centimeter is kept on U-shaped frame as shown in the figure. There is a uniform magnetic field B is equal to 0.1 P perpendicular to the plane of the frame. The slider is attached to a spring of K 0.5 N per meter, Newton per meter. It is displaced by A theta and release time in which amplitude becomes A upon A divided by E is. So in this we know the value of resistance, mass, length and magnetic field with the spring constant K, and it is displaced by A theta, and we need to find the release time in which amplitude becomes A divided by E. The shape of the slider is U. So let's see how it will be solved. So let's see the solution now. Now we know that minus kx minus ILB is equal to m d2x upon dl square. Now we'll solve this, where we know the k is spring constant, I is current, L is length and B is magnetic field. So when we'll solve this and rearrange this equation, it will be minus kx b2 p square L square upon r dx by dl minus m d2x upon dl square is equal to 0. And when we'll compare it, it will be minus kx minus b dx upon dl minus m d2x upon dl square is equal to 0, and a is equal to a naught e raised to power minus b2m into t. When we will compare these two equations, equation number 1 and equation number 2, we need to compare these two equations. It will come out to be b square I square upon r into 2m into t is equal to 1. We will get this equation once we will compare the equation number 1 and 2. And this will give us the amplitude time that we need to find, that which will be 2mr upon b square L square. We know the values of m, r, b and L which are given in the question. When we will replace these values with the which are given in the question of mass, resistance, induction and length, it will come out to be 10,000 seconds, which will be the amplitude time which we need to find.